graph here, left side graph is showing the stress strain pattern of concrete. In the left side graph, there is two parts. One is showing the compression behavior, and back the left side is showing the tension behavior. The compression behavior, in the sense that basically the concrete specimen is subjected to compressive load, and we are trying to get the stress and as well as the strain, and we are plotting it in a graph. Now the structures, when it's subjected to compressions, it can be two types. If you want to test it, you can apply the load in two ways. One is the load control, another is the displacement control. The left side graph here, this for the compression behavior is showing the displacement control curve. The right side here, it is basically, you can say, it is representing the load control graph. The difference between the displacement control and the load control is that displacement control machines can show that post-peak behavior. So here you can see when the stress is reached to the maximum value of sigma, that is represented by sigma cu. Thereafter also we are getting some softening part. This is basically we are getting because of we have used one displacement control machines. Now if you are using load control machine, in that case the structures or the specimen which is subjected to compressive load, it will reach to the maximum value. Thereafter you cannot have values. This is the basic difference between the load control machine and the displacement control machine. So now come to this stress strain pattern. So here you can see this graph is basically for the concrete, it will come as parabolic in nature, and from here you can see when the structure or the specimen reaches the maximum stress value, and you also can have the corresponding strain value, which is represented by the epsilon u. Here you will see that specimen which is subjected to compressive force in the displacement control machine, it reaches the maximum value. The maximum value we are representing here sigma cu, and correspondingly that strain is coming as epsilon u. And thereafter also, if you continue the test, you will can observe the softening nature, and this will be the maximum strain for the concrete. Here you can, after softening part, this is the failure part where the graph ends. It's basically is showing the failure strain. Now if you observe, you will find that most of the cases concrete reaches the maximum stress value at nearly the strain of 0.002. When the structure is subject to compression, in that case the maximum strain will come, or not at the maximum strain, there is stress, maximum stress will come. If we observe, we will find that maximum stress for the concrete is coming at a strain of 0.002. Basically it is showing that if you see this graph, that sigma cu value will come at the strain of 0.002, and concrete will fail at the strain of 0.003 to 0.005. So thereafter, again if you try to continue the test, in that case you will get the softening part, and at the strain of 0.003 to 0.005 strain you will get the failure load. Now Indian standard has specified different limits. It is saying that the failure strain of concrete is limited to 0.002 for structure under direct compression, and failure strain of the concrete is limited to 0.0035 under flexure or bending load, and tensile strain under the tension will come 0.0001 to 0.0002. Okay, so here you can see that failure strain of concrete under tension is almost 1/10 of the compressive force. So here we can see that since it's very brittle in nature, you will show much deformation in case of tension also. In compression also, you will not have much because the strain limit is 0.002, very low in comparison to metal. So for the same reason, we are saying that concrete is very brittle. Okay, before failure, we will not show much deformation. Basically, it is saying that you cannot get much warning if you use only concrete. So initially, you will feel happy that okay, there is no crack or a small crack, but suddenly, what will happen? Without getting any warning, the structure will fail and whole building may collapse if you do not use any reinforcement. I already discussed that concrete is very weak in tension and concrete alone cannot be used in design of concrete structures. It will fail very suddenly and failure will be very catastrophic in nature. However, you cannot avoid tensile stress always. There can be direct tensile force acting on the structures. There can be different combination load for which the resultant stress is coming as tensile force, or there can be tensile force due to the shrinkage or temperature rises also. So thus it is very important to have the knowledge of the behavior of concrete under tension, and also you should know at which moment suppose some load is acting there and due to the load bending is occurring in the structures, and you should know at which moment that the first crack is appearing. So for this course we should know what is the behavior of concrete under tension. But problem lies there, you cannot have direct tension because if you concrete is very brittle in nature, if you try to hold it in the both the side and try to pull it, there will be secondary stress near the your grip. There will be secondary stress near the grip and concrete will fail in the grip only. So it is very difficult to perform direct tensile test. So what we have to do, we have to go for indirect testing. In the high score suggested indirect testing such as bending test of the prism or splitting tensile test of the cylinder, so that we can get some idea about the quality of the concrete. Now again you will see that if you conduct the indirect tensile test or test on the concrete for the tension, you will observe that strain also is coming in the range of 7 to 15% of the compressive strain. In the last slides you observe that strain is almost coming 1/10. Here also strain for the uniaxial tension is coming in the range of 0.0001 to 0.0002, is very smaller. So now if you discuss that indirect testing, so indirect testing already discussed that we can conduct the bending test on a prism. So they give 2-point loading. Some books refer 4-point bending test. 4-point in the sense there are 2 support and there is 2-point for the loading. So if you go for the 2-point bending test, in that case we can have the maximum stress at the bottom. So if you apply the load and the stress, basically that if you apply the load, that structure will try to deform like this. This will be like this. If you apply the load here, it will try to deform like this. So the bottom fiber will come under the tension. Bottom fiber will come under the tension and the top fiber will come under compression. Here you can see it is under compression. Here it is coming under the tension. Now it is assumed that the maximum tensile stress in the bottom fiber, is coming under tension. So maximum tensile stress at the bottom fiber will reach, and we can have that load, and also we can see at which load it is failing. So we can have the maximum moment at which the crack is occurring. And theoretically also we can also calculate what is the your cracking moment, or you can say modulus or rupture. You can say that it is rupture, it is the ratio of moment by the sectional modulus. But problem is that since the concrete is parabolic, that basically you can say from the beginning concrete is so very non-linear nature. In that case you cannot have good result. Most of the case it is observed that modulus of rupture is coming in the range of 60 to 100% more than the direct tensile strain. So if you conduct one direct tensile strain test and another one if you conduct that your 2-point bending test, in that 2 cases result also vary into high magnitude. Now IS 456 has suggested that if you have the compressive strain of the concrete, you can assume some value, and that value is coming as 0.7 put under the FCK. Many times I say that concrete is very weak in tension, but it can carry the compressive force. Now question may come to your mind that if concrete is very strong in compression, then how the structure is going to fail under the compression. Now here you just see this figure, some load is acting on the cylinder. You can say suppose cylinder is there and we try to do some your compressive test. In that case suppose you have one cylinder and we are applying the force in this direction. So now what will happen if we have that compressive force. Then in some way in the middle of the cylinder there will be strain, which is basically lateral in the direction. And what is due to the compressive force? Due to the compressive force, that the cylinder will try to expand in the lateral directions, and this lateral direction will the expansion of the in the lateral direction will induce some crack in the longitudinal direction. That will come due to the Poisson effect. So you are applying low force here in these directions, and it will try to expand due to the Poisson effect, and there will be some, since it is try to expand in these directions, the crack will occur in the vertical directions. So like that, though the structure is under compression, but due to the Poisson effect there can be tensile strain, and due to the tensile strain there will be crack on the cylinder. So those structures in under compression, that also will fail under the tensile strain.